For this review problem, we have this differential equation, e to the x plus 1 times dy dx is equal to y minus y times e to the x. We want to find the solution and also find the domain of the solution. So first step, let's factor the right-hand side so that we get e to the x plus 1 times dy dx is equal to y times 1 minus e to the x. And then this is separable. I can get all the y's on one side and all the x's on the other side by dividing. So I get dy over y is equal to 1 minus e to the x over 1 plus e to the x dx. So y's are on one side, everything else is on the other side by dividing. Now I had to divide to do this, so we want to remember that for later on. Integrate both sides. Okay, now the integral of the left-hand side is obvious. The integral of the right-hand side involves something called a transcendental hyperbolic, hyperbolic function, hyperbolic trigonometric function. This is not something I expect anybody to have memorized. So here's the trick that I would use for this. I'm going to multiply top and bottom here by e to the minus x over 2. So e to the minus x over 2 times 1 minus e to the x, e to the minus x over 2, 1 plus e to the x dx. Continuing, we get integral dy over y equals integral of, here we have e to the minus x over 2 minus e to the plus x over 2, all over e to the minus x over 2 plus e to the x over 2 dx. Now, why in the world did I do that? The reason I did that is now I can use a u substitution. U is equal to e to the x over 2 plus e to the minus x over 2. If I take the derivative, I get 1/2 e to the x over 2 minus 1/2 e to the minus x over 2 dx. And except for a factor of negative 1/2, that's exactly the numerator. So integral dy over y equals integral of, let's multiply this by negative 1/2 e to the minus x over 2 minus e to the x over 2 dx over e to the minus x over 2 plus e to the x over 2. And of course, if I do that, I need to multiply by negative 2 on the outside to compensate. Okay, so the top here is going to be exactly the du. The bottom here is u. So integral dy over y equals negative 2 integral of du over u. So we integrate, we get natural log of absolute value of y equals negative 2 times natural log of absolute value of u. Okay, so, plus c. Forget the plus c. So that gives us that natural log absolute value of y is equal to natural log of absolute value of u to the negative 2 plus c. So solving for y, we get that y is equal, absolute value of y is equal to e to the c times natural log of absolute value of u to the negative 2 power. E to the natural log of something, okay, I forgot the plus here. So let's split this up. Absolute value of y is equal to e to the c times e to the natural log of absolute value of u to the negative 2 power. E to the natural log of anything is the self. Here I have e to an undetermined constant, which is just going to be another undetermined constant. So y is equal to plus or minus e to the c, which is going to be an undetermined constant, times absolute value of u. U was all the way up here equal to this. So I substitute back e to the x over 2 plus e to the minus x over 2 to the negative 2 power. And finally we get c times e to the x over 2 plus e to the minus x over 2 whole thing to the negative 2. And so that is going to, that's going to be our answer for this differential equation where c is an undetermined constant. Now it looks like the domain of the solution is going to be all real numbers. However, I have this one slight catch, which was the very, very, very first step. All the way up here, I divided by y. So I need to put over here, or y is identically equal to 0. After all, if y is equal to 0, that means that dy dx is going to be identically equal to 0. And clearly, if both of these are 0, then I would get 0 on the left and then 0 on the right. So this is also a solution. Now, sometimes I have to write that separately, other times I don't. So technically, I should write or y is equal to 0, identically equal to 0. However, I noticed that if c is equal to 0, this is exactly this. So this is actually duplicated. And so for this particular example, I don't have to write that over. It's not necessarily wrong to have this separately, but it's redundant because if c is equal to 0, I get this special case. So in this example, I have this special case that I have to worry about. And for this example, and for this example only, the special case happened to be part of this right here. So I didn't have to write out this special case separately. For other questions on this review, we'll see that will have to write out the special case separately. So anyway, there is our answer, and the domain of the solution is all real numbers.